Now, in example number 7.2, it says that we have a total of 4 resistors. And these resistors are connected in such that, for example, the first 2 are connected in series. And those would be in parallel. Now, if you want to combine, so we can combine these 2 together. So this is so because this is in series, you can just combine these 2 together. So if you add this to that, you get this quantity here. And then because this is in parallel, you can solve. So for example, you solve this equation here. You get the array equivalent here is equals to 2. All right. Then all of this is going to be in series with all of that. So add those up again together. You get 14 ohms. Does that, I think that's pretty straightforward to do. Okay. Now that we know what the array equivalent is, it says that what is the current in each of the resistors if the potential difference is 42 volts between point A and point C. So think about taking point A and point C here and connecting it to a body. This is plus and this is minus. So my delta V here is equal to 42. So how much amount of current I is going to flow? I can calculate that by just taking, so this is equal to that, which gives me this. Now, if I want to calculate the current in each of the resistors here, then I can say that, so my delta V1, which is the voltage across this. So notice that these two resistors are in. So the 6 ohm and the 3 ohm are in parallel. So it means that the V1, which is the voltage across the 6 to 0 ohm, must be equal to the voltage across the 3.0 ohm, right? So we're saying that the current is going to come here and then it's going to branch into I1 and I2. And so I can solve this equation to get this. And I also know that I1 plus I2 must be equal to the total current. So you have this second equation here. So call this equation number 1, call this equation number 2. Solve those 2 equations together, you get your I1 as 1.0 ohms, and your I2 as 2.0 ohms. Okay, now this is that example. Let's see. I was going to look at one more example here. Now let me share my other screen, and then I'm going to go over one problem here. All right, so we can just look at this example number 5. But I think the key is that if you look at this current I, as this current comes in, it's going to branch into 2 parts, I1 and I2. So let me try to zoom this a little bit more so you guys can see. The current I comes here is going to split up into 2 parts, I1 and I2. So it means that I must be equal to I1. Okay. Now let's look at this second example here. This is example number 27.5. And in this example, we have 3 resistors that are in parallel. So in parallel means that same. So let's look at this problem. So we have, again, remember that in this case, there is no internal resistance. So you can just say that your delta V is equal to that, is equal to 18. Now, if this is my R1, so this is my R1, this is my R2, this is my R3. So again, that point is called the junction. It's a junction because when the current I comes in here, it's going to split up into three parts. So I1, this is I1, and this is I2, and this is I3. So I want to stop sharing here just for a second. Let me show. So let me answer this question: how to tell if resistors this is very, very important. So the main thing is that you just want to make sure that you identify, you need to be able to identify so is there a junction in the problem? So a junction means that it's a point where current splits up. All right. So let me show an example here. Suppose I have a current that is coming in here. And then once it gets to this point, it doesn't matter how complicated this picture could look like. Maybe something like that. So let's put a resistor here. Then let's put a resistor here. Let's put a resistor here. And then at the end, everything is going to collect back at this point. So this point is a junction right there. That's a junction. And the reason why this is called a junction is because, for example, if 10 amps is coming in here, it's going to split up in such a way that 3 amps go in there, 4 amps go in there, then 3 amps must go in there. So call this I1, call this I2, call this I3, call this I. So by conservation of charge, I must be equal to I1 plus I2 plus I3. So each time that you analyze a circuit, look at the junction. This is the point where the current goes in, and then current comes out here. So if this is 10 amps, by the time that it goes out of here, it should also be equal to 10 amps. Because the I1 and the I2 and the I3 are going to combine again together. So that's how you identify if your resistors are in parallel or not. So always look for a junction to tell if the resistors are in parallel. Questions about this? Okay. Now let's go back to the PowerPoint. I just wanted to explain this because I think it's a very useful concept. So let's go back here and look at this example. So clearly in this example, you can see that there is a junction right there. The current is going to break up into 3 parts. So it means that those 3 resistors are in parallel. Now, if those three resistors are in parallel, I can just combine them using this equation here. So you combine using this equation, and so this would be my R equivalent. Now, if I know my R equivalent, I know that the voltage between this point and this point, so my delta V1 is equals to my delta V2 is equals to delta V3, which is also the same as delta V. So each of these resistors is going to receive 18 volts, right? So it means that I can go ahead and calculate the current. So for example, I1 is delta V. So because my delta V1 is also the same as delta V, I can calculate my I1, calculate my I2, and calculate my I. Now, what is I? You can calculate I total by doing delta V over R equivalent, which if you take 18.0 and you divide by 1.64. Now, if you do that correctly, you should get, let me see if I have my calculator here. Does anyone have a calculator too? I cannot find my calculator here.
10.9.
20.9.
10.
10.9. So this would be 10.9. Again, if you just, because of round up, this is almost like 11 amps. So you can see that if you add all of these, you should get the same value as that value. Okay. Now that you know the voltage and the current, you can calculate how much amount of power goes into each of the resistors using this equation here. So P1 is I squared times R1, P2 is I squared times R2, P2, P3. So these are the R's. Now, if you calculate the sum of all the powers, it gives you 198. If you calculate the total power that goes through the equivalent resistors, it's also the same as 198. So if this was in the exam, this is how you can double check that you're getting the same value. So this value must be equal to this value right here.